Okay, let's jump right in. For today's deep dive, we are getting visual with algebra.
Uh-huh. We're looking at graphical solutions for linear equations.
Hmm.
Basically, turning those strings of x's and y's into pictures.
Exactly. We've got some source material that lays out how to do this, and our mission really is to unpack those steps.
Yeah, and not just the how-to, but why it's powerful, what you gain by, seeing the math.
Right. It's more than just drawing lines, isn't it? It
Yeah.
feels like a tool for understanding the relationship between variables in a, well, much more immediate way.
It definitely is. You're solving problems, sure, but you also get that visual context, that picture of what's going on.
So let's start simple. One equation. What's the core idea there?
Okay, so a basic linear equation, like x attack grass plus by plus c cos c as y. Every point on that line, every xy coordinate pair makes the equation true.
So how do we actually, draw that line? What's the process?
Well, the usual first step is to rearrange it. Get one variable, usually y, by itself on one side.
Ah, okay. Like in example one, they take 3x plus y, 4 the dollars, and make it y 3x plus 4 terms.
Exactly. That makes it super easy to calculate y once you pick an x.
Then you just pick some numbers for x.
Yeah. Choose, say, 3 different values for x. Plug each one into your rearranged equation and figure out the y that goes with it.
And make a little table of those pairs, right?
Yeah.
Like the examples show a field 1 at a 21704 for that first equation.
Precisely. Those are your coordinates, your plotting points.
And you just mark those spots on the graph paper.
Mark 1, 1, 1 to 1, 7, 0, 4. And because you know it's linear, it makes a straight line. You just take a ruler and draw a line right through them.
And that line isn't just connecting those 3 points. It's showing all the points that work for the equation.
Every single one. Infinite points, all lined up.
And what's really neat, the sources point out, is using that line once it's drawn. If you know x, you can find u just by looking.
Totally. Find your x on the bottom axis, go straight up or down to the line, then hang left or right straight to the y-axis. Boom, there's your y.
Or the other way around, if you know y. Examples 2 and 3 show finding unknown values like a or b that way. It's very visual.
It is. Quick lookup. And don't forget those basics. The x-axis itself is just the line y dollars.
And the axis is $6. Useful reference.
And lines like 6-axis are always vertical, parallel to the axis.
While y or doll is horizontal, parallel to the x-axis. Good shortcuts.
Okay, so that's one line. But the real power maybe comes with two simultaneous equations.
Right. What happens when you need an xy pair that satisfies 2 different equations at the exact same time?
Graphically, this is where it gets, well, almost elegant. You're looking for the spot that's on both lines.
So you just draw both lines on the same graph.
That's it. Graph the first equation, get its line. Then, on the same axis, graph the second equation, get its line.
And the answer is just where they cross.
Exactly. The point where those two lines intersect. The coordinates of that single point are the x and y values that make both equations true. It's the only point that lies on both lines.
Like in example 4, they graph 3 by 2y, 2 1 4 3, and 5 by 2 1 these dollars. The lines cross at $3.
And that's your solution.
Yeah.
$72, I was $1,005. You can see it plain as day.
And the practical side, like example 6 with cost and selling price, that really makes it click.
Oh, yeah. Graph your cost line, graph your selling price line. Where they intersect, that's your break-even point. Costs equal revenue right there.
But you see more, too. You can see where the selling price line is above the cost line, that's profit.
Or below it, that's loss. The visual gap tells the story. It's not just one answer, it's the whole picture.
So wrapping up, turning equations into lines is, well, a really insightful way to see these relationships and pinpoint solutions.
It's a powerful visual tool. Now, the sources mostly show lines that cross nicely at one point.
Right, giving that one unique solution.
But what if you draw them and they're parallel, never crossing? What does that mean for the solution, graphically?
Or what if they turn out to be the exact same line, just written differently?
Yeah, how would the graph show those kinds of answers? Something for you to maybe think about. What do those other pictures tell you?